So hello everybody. My name is Carlota Pasquale. Today I'm going to present you about CDG and allies pain. And I would like to know how many of you have heard or know about CDG and allies pain. It's not too bad, but by the end of this talk, I hope that you are going to be familiar with our work and what we do, because we do it for you. So today I'm going to focus my talk on CDG and Immunology project that I'm focused with. I'm going to start by telling you how did we end up here. So it all started in 2010, where these two little friends started talking over coffee, and Vanessa, which many of you know, talked with Paulo Videira about concerns of CDG families. So she started like, CDG patients constantly have recurrent infections, and from what I hear from families, often fatal immune problems happen. And Paul is very interested and enthusiastic about immunology and glycosylation, and she got very interested. But what is the information available for families? And Vanessa said nothing. There was few evidence, and there are not specialized centers for immunology, specifically for CDG. So they decided to join efforts. So to come up with solutions to tackle directly and specific the immunological problems that happen in CDG patients. And they do that by found the CDG and Allies Professional and Patient Associations International Network, CDG and Allies Spain for short, in 2016, which is based on the Faculty of Science and Technology of Nova University of Lisbon. And it's based also on the Research Institute, UCBio, or Bio, maybe, where I'm also doing my PhD project. And here you can see our core team, which works for you every day. And how did they do this? As you know, CDG is multisystemic, so it's affected on several organs, different systems. And so they created several working groups to focus in each one of these problems. And one of them is CDG immunology. And they did this with one single goal. So our motto is to raise awareness and with the community united to improve and increase resources, research, education, and empowerment of families. So now moving on to the immune system and CDG. So the immune system is the defense mechanism that helps our body to fight the infections and other threats. So they defend our body against parasites, virus, fungi, and bacteria. But it does not always work that well. So when it is hyperactivated, for instance, you can have allergies or autoimmunity. But if you don't have a good immune response, then you have what it's so-called immune deficiency. So it doesn't quite function well. And the function of the immune system, the correct function of the immune system works because of the glycans, so the sugars that coat our cells. And this coating is called the glycocalyx that you heard about in the scientific conference. And so when this glycocalyx is defective, when there's absence of glycosylation or it is defective, for instance, the cells cannot recognize that well the pathogens or doesn't communicate well between other cell types. So, and the importance of this glycosylation is pretty visible when we consider that up to 2019, 23 CDG types were reported to have immune problems. So glycosylation is really important. So, and here in this paper, we report all 23 CDG types that have immunological problems. We also report on some therapeutic approaches that are being used. So if you want access to this paper, contact me and I will give it to you. And what are the immune-related issues? So you know better than me that your kids, many of them have infections, allergies. Some of them might have autoimmune diseases. It's responsible for a high number of hospitalizations and low quality of life. And it also reported that in PMM2 specifically, 20% leads to child mortality. And when I started immunology, I was faced with many, many challenges. So it turns out that immunology on CDG is a very neglected field. There were few collaborations in this field and others. And the immune problems often trigger other immune systems, for instance, the stroke-like episodes. And my main hurdle, it's very difficult to get funding and samples. But not all is bad. I myself have my own heroes, and I show them. Some of them are here. Not all of them, because I do have a very nice community to rely on. So thank you in advance. And these heroes allowed us to build 2 immune projects. So the first one is led by Rita Francisco, that many of you know also, and many of you might have answered this Immuno-CDG questionnaire. So it was launched with a goal to gather your experience, like what happened to you every day, about the immunology. And with this knowledge, we wanted to turn this into the lab. So we want to learn from you and take it to the lab. So these projects are complementary and are importantly focused on patient centricity, because your needs are on the center, really. So now a quick look into the Immuno-CDG questionnaire, and I am not the expert, so Rita is the expert, so I'm gonna let her explain to you about this project.
Hi, my name is Rita Francisco. I am a CDG PhD student and patient advocate. My main focus at the moment is to understand if, how, and when is the immune system affected in CDG children and adults. I am doing this by combining forces with our 2 main allies, CDG professionals and CDG families. It took a long process of optimizations, literature search and analysis, expert opinion, piloting, and reviewing, of adaptations, including translations, validation in different languages, and of communication strategies and materials. And, off the record, communication hasn't always been easy. But, in the end, we built a patient-centric tool able of systematically collecting data on immune-related manifestations reported by CDG caregivers and patients. 210 CDG patients from 31 different countries were reported. These patients represented a total of 36 distinct CDG types, with PMM2 CDG as the most represented CDG type with 122 patients, followed by ALG6 CDG with 9 patients, and in third place, SLC35A2 CDG with 7 patients. Gender distribution, as expected, was quite balanced, with 103 females and 107 males. Regarding the patient age, the majority of the patients was between 4 to 10 years old, with most also receiving their CDG diagnosis between the ages of 1 to 5 years old. Respondents were mostly moms, and they most commonly identified infections as the most prevalent and relevant immune-related manifestation. Allergies were reported for 79 patients, while the simultaneous presence of infections and allergic manifestations was identified in 50 patients. Contrastingly, only 9 confirmed diagnoses of autoimmune disorders were reported. As for vaccination, 172 CDG patients were reported to have received all the vaccines available to them. However, 9 participants said the patients lost protective antibodies quickly following vaccination, while 8 reported severe adverse reactions. With this study, we have been able not only to gather knowledge on a poorly studied topic in CDG, but we have also created the opportunity to open new research and clinical management avenues for CDG patients. However, the big volume of data we have created with this study has uncovered a series of new challenges, like redefining the most relevant clinical and research questions, or coming up with new data analysis strategies and methodologies, or even finding a way to slow down or turn back time. Well, we still haven't really succeeded here, even though we have tried a few spells and devices, but we are going to keep on trying. Do you know what else this study has generated? Well, new opportunities and outcomes in patient and caregiver empowerment and literacy. And also, it has led to the creation of a new questionnaire already administered to study immunological involvement in the general population. Why are we assessing immunological involvement in the general population, you might be wondering? Well, to accurately determine if CDG patients, when compared to age and gender-matched controls, really show a higher incidence or a greater severity of immune-related problems. So, this is part of my story so far, at least. It is far from being over yet, and it has only been made possible by you, and of course you. So thank you for being part of my story, or rather, for allowing me to tell our story.
Also, whilst in controls, the most common infections were respiratory tract and mouth or tooth infections. In CDG, also gastrointestinal tract infections were highly reported. And very, very interestingly, 19 PMM2 CDG patients or families reported to have blood infections. So this means that organ-specific infections can really spread and get generalized through the body. Regarding the age, this was something that many of you, or many of the doctors thought, like the infections really seem to be more severe or happen more during infancy, but now here it's quantified. So it turns out that in PMM2 CDG, birth to 3 years old is really the age where infections happen more. And also, PMM2 CDG patients are hospitalized mainly due to the infections. So this really is important. In terms of phenotypic severity, it turns out that if you or your child has infections or presents with infections, there is an overall increased phenotypic severity compared with controls. And having infections do reduce quality of life in PMM2 CDG patients, as you can see by the red lines. Now, very interestingly, so these are common clinical features that often are presented in PMM2 CDG patients. Well, we were able to correlate that seizures, stroke-like episodes, and increased liver transaminase do associated with infection. So this was not really understood before, or it was like a guess or a small observation that we could not be sure. But here we do have data to tell us that infections can really trigger these other manifestations or be triggered by. And on the other side, there are manifestations that only correlate with the phenotypic severity and not with infections. For instance, proteinuria, nephrotic syndrome, protein-losing enteropathy, and thrombocytopenia. So now, going a bit to my project, to my area of expertise, I'm going to give you a quick introduction with a video, and then explain more later.
Hi, my name is Carlota Pasquale, and I'm a PhD student, researcher, and CDG patient advocate. I started to belong to the CDG community with the goal of performing laboratory studies to understand the cause of immunological problems observed in CDG patients. But how? We essentially need three things: motivation, CDG samples, analyze. Since day one, motivation and determination were always present. However, to gather samples, analyze, was hard work. In 2016, I started an expedition inside and outside Portugal. After a long and hilly journey for 3 years with many challenges, we identified and recruited partners worldwide that joined our quest to collect samples. Of course, none of this would be possible without our secret weapon, the allies. With the help of doctors, researchers, and CDG families, we are in the right path now to understand the difference in the immune response between healthy individuals and CDG patients. Let me explain my project. Healthy immune cells use their sugars to recognize bacteria or viruses and other threats. This recognition will make the genes inside the cell work more intensely in a process called gene expression. As a result, more proteins important to recruit other cells to kill the bacteria and viruses will be produced. However, because glycosylation is essential, in CDG patients, one or more steps can be dysregulated, and that's what we want to learn more about, to hopefully identify new therapeutics.
Okay, so this was a very simple explanation of the complexity of the immune system and its processes. So my work started during my master thesis to understand this difference in the capacity of patient immune cells to respond to stimulus in comparison with controls. So I analyzed PMM2CG patient cells in comparison with a sibling without mutation. And this is only a proof of concept because in that era, I didn't have access to samples. But we were able to demonstrate that patient cells seem to divide more when they are stimulated with a pathogen and that they get more activated to fight the infection. But this does not really correlate with the higher immune infections that are seen in CG patients. So we came with the hypothesis that there's just the deregulation of the homeostasis, so it's like the natural state of correct functioning of the body. And also, there is a possibility that we might be facing like immune exhaustion, which is basically a state where cells do get activated, do divide, but can't fight it that well. So the function is affected. So this was proof of concept, but then we built more complete, high-quality project, which is my PhD project, to assess it at the molecular and cellular level. So the goal here is to compare CG patient samples with those ones are the controls. And besides collecting the clinical data that already exists and that can be collected by the Immunology questionnaire, also analyze patient cells. So whole blood, which has all the immune cells, but also fibroblasts. And after doing this simulation, which is like mimicking infection context, then we are going to be able to characterize functionally these cells, so the state of activation, the proliferation, migration, and then analyze the gene expression using transcriptome, which basically allows us to analyze all genes and how much they are being expressed in comparison to the controls, and also the secretome, which is basically what proteins are being produced. But then you ask, but why are you analyzing fibroblasts? They are not an immune cell. But my proof of concept here is that they actually are a good model to analyze immune function. This preliminary study, in this preliminary study, I stimulated PMM2CG fibroblasts with an inflammatory stimulus, and I was able to see more than 300 genes differently expressed before and after the stimulation. And by gene ontology analysis, which is basically a set of different terms that classify a gene based on their function. This analysis told us that there are a lot of immune processes that are being altered and regulated in fibroblasts. So it turns out that fibroblasts can be a study model for immune dysfunction. So now we do have these samples, or we do have ELISA to provide us with those samples, because we are not in a clinical environment and this is hard. So we are going to proceed also in this manner. So both immune cells and fibroblasts. And the future is very promising. So the next steps are going to compare these immune response from controls NPMM to CDG, but also more severely affected CDG types, for instance, mutate CDG. But we still have this hurdle. So the cost per sample, it's around $2,000 per sample, which it's hard, especially in Portugal, where we are a very small country, and most funding is going to common diseases, which isn't fair, but still. Still, we were very lucky to have found Heather and Matt in Lisbon, and so they kick off. They were able to fundraise for us. They were very interested in our research. So now we are going to be able to kick off, and we secure the funding to analyze the first 4 patients, which is going to be very soon. So as for the conclusions, I hope to have showed you that the key word here is collaboration, because alone we can do nothing about it. So I'm very fortunate to belong to this network of 41 collaborators, and also consider myself part of your families. As the second conclusion, difficult roads often lead to beautiful destination. Starting this research was not easy from the beginning, but I can see that the destination is beautiful. So me and Rita started Immunology. We didn't have any funding. It got so close to our hearts that we continue applying for funding every month or every 2 months, I don't know. But in the end, we were able to secure our funding for PhD scholarships, which are never or almost never dedicated to rare diseases. And this kind of proves that our project have quality and have impact in patients' lives. And to finalize, I'm going to share with you two recent, how do you say it? Projects, not projects, but yeah, missing the word. Yeah, project, whatever. So the first one is the World CDG platform. So if you were at the conference in 2015, one of the biggest needs that the CDG community told us was that there was the need for a platform at the global level where everybody needs to be there, everybody needs to collaborate there, and that can be like the place to go if you are interested, if you want to make a project happen, you can go there. Like everybody can be informed and then redirected to whatever they need. And then the second project is about the Rare Disease Day. So we have our postcards just outside. So this is a joint effort to raise awareness in CDG. So please take them, share it with your friends, with your families, with your coworkers, because if the more people that know about CDG, the more people that can help, the more people, well, you know the idea. And finally, I just want to invite you to the 5th World Conference on CDG that is in Lisbon, and finally have a date, which is the 15th and 16th of May in 2021. And it's good to say that it's 10 minutes away from the beach. And I just want to thank everyone for listening to me, to my wonderful team in Portugal, CDG Care for inviting me, Heather and Matt, and also and Bobby and Guy for the samples to kick off the project, and all the members of CDG and now Spain. Thank you.